Despite a wide range of research on the solar system of humanity, new discoveries continue to surprise us. For many years we believed that we had decided all the planets until we were wrong. But what about Voyager's probe? How far have they went out of our solar system? Even scientists were surprised by the innovative understanding provided by these spaceships. One of the most interesting revelations is that the entire solar system, including ORT clouds of almost annual aesthetics, is surrounded by a huge spatial bubble. This bubble is surprisingly 1,000 light-years, and the Sun is near the center. But what happened when Voyager research crossed our solar system? How can we actually be trapped in this huge space bubble, and how this discovery changes the understanding of the structure of the solar system? On September 5, 1977, NASA Voyager 1 spacecraft, published by Cape Canaveral of NASA Voyager 1 Florida, boarded a Titan center missile just a few weeks after Voyager 2 was released on August 20th. This stable probe, which was originally developed for a 5-year mission to study external planets, surpasses all expectations and continues to send data to Earth after 44 years. The Voyager mission uses a rare planet leveling, which allows the rare planet leveling that occurs once every 107 to preserve limited fuel by performing gravity slingshots from one planet to another planet. Despite the second launch, Voyager 1 focused on this planet, which was first reached in Jupiter and Saturn, and Voyager 2 was investigated for 10 years by Jupiter, Saturn, Changwangxiang, and Neutral. The data transmitted by the sailing deeply formed our understanding of the external solar system and occupied its position in textbooks and media. With a unique touch, each spaceship has a golden capsule of gold-green recording designed to communicate with potential alien life. As of January 2024, Voyager 1 is the farthest human being in the universe, 158 times the distance between Earth and the Sun, about 14.9 billion miles away from Earth. Voyager 2 reached a significant milestone in November 2018 and became the second spacecraft and entered the interstellar space after the historical breakthrough of Voyager 1 in August 2012. Output from heliosphere of the extensive bubbles of the loaded particles formed by Voyager 1 Sun anew was confirmed when a plasma wave device found a powerful solar implementation between April 9th and May's TOSTY buput. This buput vibration, major researchers have found that the electronics outside of heliosphere are much higher than that. The results emphasized amazing contrast, and interstellar space is more dense than the region near the Sun, but the external boundary of heliosphere is much less dense than the region closer to the Earth. Scientists who analyzed these data monitored electronic fluctuations and monitored solar particles, and decided to make the official penetration of Voyager 1 as an interstellar space by August 25, 2012. Voyager 2 crossed the interstellar space 6 years later, followed his example, and confirmed the deep scientific importance of the spacecraft. Data on the Voyager spaceship shows many similarities, such as the total density of the particles found in interstellar space. Nevertheless, their journey also found a noticeable difference and raised a new question about the trajectory of the Sun through the galaxy. Cosmos continues to challenge our expectations, and Voyager 2 observations provide a greater understanding of this extensive and mysterious boundaries over Helios. The boundary between heliosphere and interstellar space shows the deepest mystery of the solar system. In order to fully understand the revolutionary discovery Voyager 2, it is very important to first understand the dynamic essence of the Sun. Unlike the quiet appearance, the Sun is a huge reactor and passes through a galaxy of about 450,000 kilometers per hour. Its surface is a complex magnetic field network that produces a constant flow of electrically loaded particles known as solar winds. This solar wind expands in all directions and carries the magnetic field of the Sun from a distance. In the end, he meets an interstellar media that is filled with the remnants of ancient explosions. Oil and water, solar winds, and intermediate mediums resist mixes and form a separate boundary known as heliosphere. This extensive foam, which was settled by the Sun wind, extends about 11 billion miles in the Sun and encapsulates both the Sun, 8 planets, and a large part of the solar system. Isn't it strange? But this is a strange thing that works in favor of us. Heliosphere acts as a protective shield and protects everything inside, including the United States from the most dangerous radiation of the galaxy. Without this, as we can see, life will be exposed to potentially deadly danger. The outer edge of the heliosphere, called Heliopause, represents the beginning of interstellar space. Understanding this border gains deep consequences to understand the movement of the Sun through the galaxy. Scientists are interested in interactions with this critical value for solar winds and interstellar average combinations, borders along the border, and the dynamics of this universe conflict. When Voyager 1 crossed Heliopause in 2012, he saw the first direct eye in this mysterious area. But data analysis was difficult. Scientists have shown that interstellar magnetic fields are 2 to 3 times stronger than expected, which indicates that interstellar particles show 10 times more pressure on heliosphere than previously evaluated. Nevertheless, the conclusion of Voyager 1 was incomplete because his plasma device failed in 1980 and left a difference in data. In 2018, Voyager 2 provided a decisive breakthrough. Scientists have received a clearer picture of heliopause, thanks to the plasma devices. When the spacecraft approached the border, they showed the main details of this important interface because the plasma was slowed down and heated and hardened. In addition to heliopause, interstellar media are much hotter than expected, and the temperature reaches 54,000 degrees Fahrenheit or more. However, because the plasma is very thin and spread, the total temperature around Voyager probe is very low. Voyager 2 also confirmed that heliopause is a porous boundary where particles can move in both directions. For example, Voyager 1 met 10 interceptor streams that penetrated Heliopause, and it is similar to the roots of the tree through the stone before the border is completely crossed. Voyager 2, meanwhile, found a thin low-energy particle flow that extends 100 million kilometers in heliopause. When Voyager 1 approached the border, the outgoing Sun was slowly slowed down, creating a terrible pause. On the contrary, Voyager 2 observed a unique transition in the solar winds that are similar in width along the fixed area observed by Voyager 1. In the same way, the solar system is adjusted with chameleon, so there is a puzzle that requires a wider understanding of heliosphere. Voyager 1 put heliosphere on the front edge and faced the interstellar media, and Voyager 2 passed the left side. Nevertheless, waking up in heliosphere remains unknown and left a general form of uncertainty. This can be spherical due to interstellar average pressure or a comet similar to a comet or glass shape. Unfortunately, the current spacecraft does not provide a final answer. NASA's New Horizon will lose power for 1 billion miles in the 2030s. This limit required efforts to study subsequent interstellar missions, various generations of solar systems, and other achievements. With the data of the 2 points alone, the understanding of the structure of heliosphere remains incomplete, so additional data is critical. In addition to heliopause, Voyager 1 made an interesting discovery of a constant winging distance. After entering the interstellar space, the plasma wave device discovered the fluctuations of interstellar gas due to solar activity. However, there is a weak and continuous signal between these bursts. Over 1 billion years, Voyager probe will go beyond our solar system to pass through vast interstellar space. Until then, Voyager 1 and 2 are hardly recognized, and when the energy circle is exhausted, the tool is silent for a long time. Nevertheless, they will remain on a trip that passed through the galaxy in the course, which will ultimately carry them in the Sun for 50,000 years along the Milky Way. Voyager 1 is on the way away, now known as AC 793888, and Voyager 2 goes to Rosa 248 of constellation Andromeda. Nevertheless, tens of thousands of years before the probe goes to the star. Since they continue to Odyssey, the most interesting discovery in the next 3 to 5 years can be except our bold imagination.